Hello there. So it's me again. Today we are going to look at the application of derivative. So this video will cover section 3.03, the second derivative and concavity, 3.04, the second derivative test, and we will be covering a little bit on the basics of graph sketching. Okay, let's get started. Okay, before you learn how to what is the relationship between second derivative, how do we find inflection point, minimum point, maximum point. Let's take a look at some of the basics in functions. Okay, so this section will cover some of the basics in graph of polynomial functions. We have many different types of functions. First, let's take a look at this degree. Degree 1, degree 2, degree 3, degree 4. Degree means that the highest order of x. Let's say we have an equation x power of 3 plus x power of 2 plus x plus a constant 3. So this equation, we just concerned about this. The higher power of x is 3. So this is degree 3. So this is a cubic function. Now, if I have an equation y is equals to, let's say, a is a constant, which is, let's say, a greater than 0, you have this straight line. Okay, of course, if your a is smaller than 0, the graph will looks like this. You have a line, horizontal line on the negative side of your y-axis. Now, linear function, it's, let's say, y is equals to a power of x. So if the a is positive, you have a graph moving up like this. If your a is smaller than 0, you have a graph like this. So quadratic functions, okay, we are very familiar with this. Without quadratic functions, you will not have a smiley face. Okay, so quadratic functions is the equation with the power of 2. Okay, let's say x squared plus x plus 1. This is an example of quadratic functions. Okay, if the variable, the constant here, a, is larger than 0, okay, so you have a smiley face, which looks like this. If your a is smaller than 0, you have a sad face, which is, in other words, you have a maximum point. Okay, we will take a look at more at this later. Okay, so cubic function is the equation with the highest power here is x power 3. So if the variable, sorry, not variable, the constant here, a, is larger than 0, you have a graph that looks like this. Okay, this you have this graph when your a is smaller than 0. And now let's take a look at quadratic functions. Quadratic functions mean that you have a degree 4. So let's say y is equals to a x power 4 plus bx power 3 plus cx squared plus dx plus e. Okay, something like this. And if the a here is larger than 0, you have this w sign. W sign here, okay, you can see you got 2 minimum points and you get 1 maximum point. So if your a is smaller than 0, you have this kind of graph. Okay, everyone love this. This is McDonald's actually. Okay, now quintic function, we will not going into this. Okay. Okay, now we are going to see slope. It's actually our gradient, which is also our first derivative. So if you have a slope like this, it also means that it has a positive gradient. If you have a negative slope, it also means that it is a negative gradient. So a negative gradient also means that you are going down here. Positive gradients means that you are going up here. So if you have a zero slope, means that it is a horizontal line, and the vertical line we don't have gradient. It's called undefined slope. Okay, so if I have a slope, let's say dy dx is greater than 0, you have this positive gradient. If you have your gradient dy dx is smaller than 0, you have this negative gradient. If I get dy dx is equals to 0, you will get a 0 slope. Okay, now let's take a look at this. If initially, let's say I have a slope like this. So my gradient of this line, okay, it should be quite large, okay, because this is actually quite steep. So let's say this line is becoming more and more like this. What happens to this value dy dx? Is it increasing or decreasing? Okay, so the answer is the dy dx, the gradient is actually decreasing. Correct, getting less and less steep. Okay, so if I have a gradient like this initially and it became more and more steep, so what happens to the dy dx here? So the dy dx here actually keeps on increasing, and became more and more steep. Okay, now let's take a look at the second derivative. So the second derivative can be written as d square y dx square or y double prime, okay, or f double prime x. So now, what does second derivative have to do with the shape of the graph? Okay, if the second derivative is positive, the function is concave up. Okay, so in other words, the second derivative is positive. You have this graph, the shape of the graph should be concave upwards. So concave upwards, there's actually two kinds here. It's either like this or like this. Both of these are, we call this as concave upwards. Okay, so if your second derivative is negative, okay, smaller than 0, you have the shape of the graph should be concave downwards. Okay, so concave upwards, we call this as a cup shape, and concave downwards, we call this as a cap shape. Next, we are going to look at what does it mean by point of inflection. Okay, point of inflection happens when where the concave downwards join with your concave upwards. So it doesn't matter if it is like this or it is like this. Okay, when your cup meet your cap, and they will have a spark in between. This point we call this inflection point. Okay, so inflection point, we have two types of inflection point. We have this is also called the oblique inflection point. Okay, forgive my handwriting. Trust me, my handwriting is better in person. Okay, and second type is horizontal inflection point. Okay, you can just call this horizontal inflection point. So horizontal inflection point, what is the difference between a oblique inflection point and horizontal inflection point? The horizontal inflection point, the gradient at this inflection point, it is actually equals to 0. Okay, so you see the gradient at this point, if you draw a gradient, you draw a tangent, okay, at this point, the gradient is not equals to 0. If it is 0, it means that the gradient is horizontal, the tangent is horizontal, it is called horizontal inflection point. So a horizontal inflection point is both a stationary point and a inflection point. Okay, now, so let's see about this cubic graph. So we have a cubic graph here. Okay, so you want to see where is the inflection point. So, okay, so the first thing you can see here, the black line here actually is the gradient of the tangent, okay, at this red point. So this gradient, is it positive or negative? Okay, this gradient, very obviously this is a positive gradient. So as this point move along this graph, you discover that the gradient increasing or decreasing. Okay, from left to right, it is actually decreasing until it reaches a certain point, it becomes 0. So this 0, the first gradient equals to 0 here actually is our maximum point. So after this maximum point, the gradient keep on decreasing, more and more negative. more and more negative, more and more negative, until a certain point you see the gradient actually started to increase again, increase until it become zero again. So this zero is our minimum point, and then it keep on increase more and more negative. So inflection point actually is the point where somewhere in between here, okay, means that it is from decrease, the gradient decreasing, and suddenly it became increasing. So on that point actually is our inflection point. Okay, just now we already saw how we get this inflection point in two different methods. First, we can get it, the inflection point happens between your cup and your cap. Okay, it doesn't matter the cap with your cup or a cup with your cap. It is when your concave down meet your concave up, or your concave up meet your concave down. Okay, the point in the middle when they meet is actually called inflection point. So just now another slide I've shown you the gradient, right, on the cubic graph. So inflection point is where the concavity change, means that the gradient decrease. Let's say it's a decrease. Suddenly there's one point the gradient started to increase again. So that point is actually an inflection point. So mathematically, how are we going to find inflection point? Let's say given any equations. So we need to do this. So if you let second derivative equals to 0, we can find inflection point. Okay, now let's take a look at stationary points. Stationary point, we have three kinds here. First is the minimum point, maximum point, or a horizontal inflection point. Okay, three of these you will have the gradient is equals to 0. Okay, so if you have a minimum point, you know the gradient, the tangent at this point, the gradient is equals to 0. Okay, same happens here. Okay, this is a horizontal line, so the gradient is also equals to 0. So how do we distinguish this? Let's say I'm being blocked by a police. So and let's say I have a long hair. So the police ask me, are you a male or a female? So what should I do? Do I just tell the police, okay, come, follow me to the washroom? No, right? Okay, I must prove myself I am a male. So I just, the simple way is to show him the IC. So same happens here. So if I want to show whether the points is a minimum or a maximum, we have to do the second derivative test. Okay, so the second derivative test is like a simple test. It's like I showing the police my IC. So this second derivative test will tell us whether the point that we found is a minimum or a maximum point. Okay, so if my second derivative is greater than 0, I got a minimum point. If my second derivative is smaller than 0, I get a maximum point. Okay, so how to memorize this? Second derivative greater than 0. Greater than 0 means I got more money, right? So I am happy. So if you are happy, then you got a smiley face. So a smiley face, look at the mouth. Okay, so we have a minimum point. If my second derivative is smaller than 0, I got less money, so I'm not happy. So I got a sad face here. Sad face is a maximum point. Okay, and for inflection point, okay, we need to do sign test. We must show that the point we found is an inflection point by doing sign test. Okay, we will come to this again later in example. So if the sign changes, this proves that the point itself is a inflection point. If the sign doesn't change, we will take a look at this later. Okay, if the sign doesn't change, so the sign should change. Just now we have seen that, okay, this is a cap shape, this is a cup shape. Okay, so a cap shape, you should get negative, this is positive. So the sign changes from negative to positive, or from positive to negative. If the sign doesn't change, it from positive to positive, it is a minimum point. If the sign doesn't change, it is from negative to negative, it is a maximum point. Okay, don't worry. I know you guys don't understand this. We will come back to this again later. Okay, as a summary, to locate stationary points, we need to do this first derivative equals to 0, and then we substitute it into the second derivative. See the value we get, whether it is greater than 0 or smaller than 0. So greater than 0, okay, got more money, I'm happy. So this is a minimum point. If my second derivative is smaller than 0, I got less money, I'm not happy. Okay, so I got a maximum point. Okay, now let's take a look at the summary of the shape of the curve given the first and second derivative. Okay, if my second derivative is greater than 0 from what we learned previously. Second derivative greater than 0 tells us that it is concave upwards. So for concave upwards, we have two kind of shape. So it's either this or this. So to identify which one is which one, we have to look at the first derivative. So the first derivative tells us the gradient. So for the gradient positive, okay, the gradient positive, you have the gradient like this. For gradient which is negative, you have a gradient like this. Okay, so which one of these is it, the one in the left or the one on the right, will give you the gradient positive? Okay, the answer is this one, because if I have point here, the gradient is positive. So if your second derivative greater than 0, first derivative also greater than 0, so your shape of the graph should looks like this. Okay, so if your second derivative greater than 0, first derivative smaller than 0, you have a graph looks like this. Okay, because the gradient here at this point, okay, is negative. Okay, and if we have second derivative smaller than 0, second derivative smaller than 0 tell us it is a cap shape. So we have two types of cap shape. Both are concave downwards. Okay, so which one is which one? So we take a look at the gradient. Which one will give us a positive gradient? Okay, very obvious is this one, right? So second derivative smaller than 0, first derivative greater than 0, you have a graph looks like this. And this one will be the next one. Second derivative smaller than 0, first derivative smaller than 0. So we have a negative gradient. So the gradient here is negative. Okay, now let's take a look at what happens when first derivative equals to 0. Okay, first derivative equals to 0, we know it might be a maximum point or a minimum point. Okay, so which one of these is a maximum or which one is a minimum point? Easy, we just join both of these together. So if I join both curves together, you should get a complete curve, right? So this is a minimum point. If I join both caps together, you should get a maximum point. Okay, this makes sense as what I said in the previous slide. First derivative equals 0. Second derivative greater than 0. Greater than 0, I got more money, so I am happy. Happy, I got a smiley face, so you got a minimum point. First derivative equals to 0. Second derivative smaller than 0. So you got a second derivative smaller than 0. So I got less money, I'm not happy, so it is a maximum point. Okay, and second derivative equals to 0 is basically what? When we want to look for inflection point. And to find inflection point, it has to undergo sign test. So if the sign changes, it is an inflection point. So we have two types of inflection point. Okay, oblique inflection. Okay, it's either like this or like this. So which one will give a positive gradient? Okay, very obvious is this. So an oblique inflection point with a positive gradient should looks like this. Okay, here if I draw a, this point is an inflection point. So if I draw a tangent here, the gradient should be positive. Okay, so if I draw a tangent here, the tangent should be negative. Okay, so if I have an inflection point where the gradient of the inflection point is equals to 0, it is an horizontal inflection point. Horizontal inflection points means that the gradient at this point is equals to 0. Okay, and if my second derivative equals to 0 and then I do sign test, so I show the police my IC, okay, I do sign test and it is positive nearby. Positive nearby comes to here. Positive nearby means that it is a cup shape, so this is a minimum point. If the second derivative is equals to 0 and it is negative nearby, means that I do the sign test, but both give me negative. Negative means I will come to here. So I will have a cap shape. So this is actually a maximum point. Okay, now let's summarize this. So by doing first derivative equals to 0, I can find stationary points. To identify whether the stationary point is a maximum point or a minimum point, I do second derivative test. Okay, so if my second derivative is greater than 0, more money, I'm happy, so it is a minimum point. If my second derivative is smaller than 0, so I'm not happy, I got no money, so it is a maximum point. So if I want to look for inflection point, I have to do the second derivative and equals it to 0. And then I do the sign test. If the sign changes, let's say from positive to negative or from negative to positive, means that it is an inflection point. Okay. Okay. If both, let's say I find out the point from by doing second derivative equals to 0, I found out a point. And this point, the coordinate is exactly the same as this point. Means that, let's say I have a point, let's say this point 2, 3. This point, the first derivative equals to 0. Second derivative also equals to 0. This tells me that the point is an inflection point. But the first derivative tells me okay, the inflection point is a horizontal inflection point. Okay, don't worry. Let's take a look at examples. Okay, now let's take a look at the example. Just now I keep on mentioning sign test, sign test, sign test. You must be wondering how is it, how to do a sign test. Okay, we'll take a look at this. Let's say the exam question sounds something like this. Identify any stationary points and inflection points on this equation and determine their nature. Okay, so we have to find the stationary points and inflection point. Determine their nature. Determine their nature means that I have to identify whether the stationary point is a minimum or maximum point. The inflection point, is it an oblique inflection or a horizontal inflection? Okay, so we have this equation. Y is equals to 2x power 3 minus 9x squared minus 24x plus 30. Okay, first we find these stationary points. I know first derivative equals to 0. This is where the stationary point happens. So by doing first derivative equals to 0, so I differentiate this. So differentiate this, you will get 6x squared minus 18x minus 24. First derivative equals to 0. Okay. Then I can simplify this. I can factor all this by 6. So it will be left by x squared minus 3x minus 4 equals to 0. Okay, and then I can factorize this. So you will get x minus 4 and x plus 1 equals to 0. Okay, so I got my x value. x is equals to 4 or x is equals to -1. Okay, so I have the x coordinate, okay, of both of the point here. The question asks for the points. Is this a point? No, this is not yet a point. So we have to find out the y coordinate. When my x is equals to 4, okay, what is my y value? So just substitute it back to the x equation. 4 power 3 minus 9, 4 square minus 24, 4 plus 30. Okay, you will get -82. Okay, so I have found out my first point here, 4 and -82. So the second point, it happens when my x is equals to -1. So when my x is -1, okay, substitute -1 inside the equation plus 30. Okay, so you'll get your y coordinates is equals to 43. So I have the second point now, which is -1, 43. So both of these points are stationary points. So I want to know which one of these is a maximum point, which one of these is a minimum point. Okay, so now I do second derivative. Correct. So second derivative means that I differentiate the first derivative again. So the first derivative is equals to this. So the second derivative means that I differentiate this again. I will get 12x minus 18. Okay. So I want to know which point is a minimum or maximum. So I substitute the x coordinate here. When my x is equals to 4, the second derivative, okay, the value that I get here is 30. Okay, 12 times 4 minus 18, you get 30. 30 is greater than 0. Greater than 0 means I got more money, so I'm happy. Happy, so we got a smiley face. So this tells me that this point 4, -82 is a minimum point. Okay, this is how we do the second derivative to identify whether the point is a minimum or a maximum point. Now let's try the another point. If I substitute x is equals to -1, okay, 12 multiplied with -1 minus 18, you will get a negative value. Okay, -12 minus 18. -12 minus 18, you will get -30. So -30 is smaller than 0. So second derivative smaller than 0. I got less money, so I'm not happy. So you get a maximum point. So now I know this point, -143, is a maximum point. Okay, in exam, don't draw this smiley face. Okay. Okay, so we have found out a minimum point and a maximum point. Now we want to look for this inflection point. So to find the inflection point, we have to assign second derivative equals to 0. Through this, we can find the inflection point. So we already did the second derivative here. So we got 12x minus 18 equals 0. So 12x is equals to 18, x is equals to 18 over 12, which is equals to 1.5. Okay. So 1.5, okay, not yet a point. Find out the y coordinate for this point. So substitute 2, 1.5 power 3 minus 9, 1.5 square minus 24, 1.5 plus 30. Okay, with the help of my finger, okay, I found out this is equal to negative 19.5. Okay, so I have found out another point here. 1.5, 19.5, negative 19.5. Okay, As I said just now, this point, to show this point is an inflection point, we have to do the sign test. Okay, now let's see how to do a sign test. It's very simple. You just draw a table, and then this is your x value. This is your second derivative. Okay, and then the x value we found here, 1.5, we put it in the middle. And we find a point before this and a point after this. Okay, which is easy to substitute inside the equation. So I know if I substitute 1.5 inside the second derivative here, I will get 0. Okay, definitely you will get 0 because this is what I get when I equals it to 0. I found out this point. If I do it reversely, I will get back 0. Okay, so I find a point before 1.5. Which value is easy to use? It's obviously 1. So if I substitute 1 inside here, 12, 1 minus 18, do I get a positive or negative? Okay, I get negative 6, right? So it is negative. If I substitute a point after 1.5, let's say I choose this 2. So if I substitute 2, so 12 times 2 minus 18, 24 minus 18, okay, you will get 6, which is positive. So this negative became 0 and then it became positive. This is the sign changes, okay, pay attention here, the sign changes. The sign changed from negative to positive. So this tells me that this point 1.5 and negative 19.5 is an oblique inflection point. Okay, so that's it.